Hi, I'm Maciej, I'm a software engineer. In my previous video, I have complained about compilers that complain about correct code, and I have mentioned data flow analysis. I think this is something worth explaining. So here it is. Data flow analysis is quite a complex subject that refers to the set of possible values that objects can acquire during the execution of the program. There is a lot of theory behind it, but all this theory is not necessary to have a useful intuition to reason about this concept. So the idea is that as the program moves on, objects acquire values that depend on other objects and on previous computations. This sounds simple, but what makes it complex is the presence of conditional branches that can influence the sequence of actions in each execution. Why is this interesting at all? Well, compilers need this information to take optimization decisions, so this has a pragmatic value. But even before this optimization stage, there is a question of program correctness. That is, whether information has the right source and the right destination. And we can reason about this in terms of object dependencies. Take, for example, a simple function that adds two numbers. The result depends on both parameters, and we can even show it on a diagram. If I make an error in this function and I use only the first parameter, then the result will depend only on that first parameter, and nothing will depend on the other one. And again, this can be seen on a diagram. As you can see, even in such simple cases, object dependency diagrams can be a useful tool to reason about program correctness. Things get a bit more messy if a single object is used to hold many different values during the program execution, and this happens a lot in programs written in imperative programming languages. Take, for example, this function that just for presentation adds four numbers doing one addition at a time. The return value is built in steps, but we can still keep track of all dependencies using a simple trick of versioning objects after each modification. All such diagrams have two important expected properties. Every object should depend on something, and for every object, something should depend on it. In other words, every object should be both a source and a destination for some data flow. In short, something goes in and something goes out. What if this is not the case? It's very simple. If an object is not used as a destination for some data flow, then it's never initialized, and this is a programming error. And if it's not used as a source, then, well, it's useless. Let's take, for example, the simple test program from my previous video. You can see that variable x is used as a source of information for function parameters, but it's not used as a destination for any data flow. This means that variable x is not initialized, and this is an error. The second example was more involving, but after marking all objects with version numbers, we can see that everything is correct. And this can be seen on the diagram as well, even in the presence of conditional statements. And we can also see that the dummy initialization, which was added to shut up the complaining compiler, actually destroyed that harmony. This can be seen also on the diagram because the initialization value was never used further during the execution of the program. Is such additional initialization a problem? Yes, it can be, because it can mask the actual error when the programmer really forgets to assign values as expected. Everything will look good, and tools or even humans might miss the error. Be careful with coding standards that force you to initialize everything as a matter of defensive coding style. Code analysis is a much better defense than smoke and mirrors. And remember, something goes in, something goes out. I'm Maciej, I'm a software engineer. Write some good code and see you next time.